There are several very common operations on linked lists. Some that we've done already, for example, adding an element to the end of the linked list. That's probably the most common operation since we're always adding elements to the end of the linked list when we're creating a linked list. Traversing the linked list is something else that's very common, so going through the linked list one element at a time in order to do some operation on every one. Some other operations that are very common include inserting an element somewhere in the linked list. So you might have what you would call a current element, for example, and you insert after that, wherever that happens to be, or deleting an element from anywhere in the linked list. It's very important when you're working with the linked list to always maintain the integrity of the linked list. So that means that the first pointer always points to the first element, the last pointer always points to the last element, the last next pointer has the default value, for example, null in many systems, and the list is actually linked together with all of the next pointers. So whatever operation you perform, whether you're inserting something or deleting, you always have to make sure that these things are true. Also, you should always write general code that will work on all elements. So for example, if you're deleting, if you happen to be deleting the first element, then you'd have to move the first pointer to point to the new first element. Or if you happen to be deleting the last element, then you'd have to move the last pointer to point to the new last element and make its next pointer the default value, for example, null. So you have to be careful when writing code that you're taking care of all possibilities and that you're always maintaining the integrity of the linked list. So let's take an example of a common operation. Let's delete the first element in a linked list. So I have my first pointer pointing to this first structure, this first element in the linked list. So if I want to delete that, then I want first now to point over to the next element. So instead of pointing here, it's going to point over here. Now, if I wanted to somehow free up or deallocate this space, then I would have needed to have some kind of a pointer, current pointer, for example, pointing over to the next element so that I could then free this up and still have first point to this location. So that's the basic idea. You need to make sure that first always points to the first, last always points to the last, and so forth.